Hola clase! Today we are going through the proof of the trigonometric identities. Before getting started, there are a couple of things I need to know. I need to know the functions of the sine and the cosine of an angle as projections of a rotation. I need to know them as proportions within a right angle triangle, and I need to know the reciprocal reasons. Remember that when we see sec of alpha, cosec of alpha, or cotangent of alpha, it's the secant, the cosecant, and the cotangent. Let's start placing an angle within the goniometric circumference. Remember that is a circumference with a radius of 1 centering the origin. And let's call it theta. That angle has a vertical and a horizontal projection. We are respectively the sine and the cosine of that angle. At the same time, I can use that angle to create a right angle triangle, which will have 1 for the hypotenuse, and then sine of theta and cosine of theta as the short sides. This triangle is right angle, and I have Pythagoras' theorem telling me that the hypotenuse square equals a square plus b square. So I can substitute in there. 1 square would give me 1 equals sine square of theta plus the cosine square of theta. And this is so basic and important that we call it the fundamental identity of trigonometry. From this one, I can play a bit with my reciprocals, and if I divide everything by the cosine square of theta, I just divide both sides by it, then I can simplify, because I know that 1 over the cosine is the secant, so this would turn into the secant square of theta, and in the other side I've got a sine over cosine, which is a tangent, and a cosine over cosine, even if it's square, will be a 1. So that gives me that the secant square of theta equals the tangent square of theta plus 1. I can follow the same idea, but instead divide by the sine square of theta. So I take the fundamental identity and I divide both sides. The left-hand side, now, because it's a reciprocal, I know that this is the cosecant square of the angle of theta. And in the other side, what I've got is a sine square over sine square, which would be 1, and then a cosine over sine, even if it's square, that is a cotangent. So in our case, a cotangent square. So now I know that the cosecant square of theta equals 1 plus the cotangent square of theta. So the last step, I'm just going to group them all together. The fundamental identity, 1 equals sine square of theta plus cosine square of theta, and the two equivalent expressions, but they're using different trigonometric reasons. Secant square of theta equals tangent square plus 1, and the cosecant square of theta equals cotangent square plus 1. And these three identities I've got in my formula sheet, so now that I proved them, they're ready to be used in our exercises. Now it's your turn to go and practice. Thanks for watching.